How are you today? Today we are going to discuss on solvent effects on SN1 reactions. The SN1 reaction goes much more readily in polar solvents that stabilize ions. The rate determining step forms two ions, and ionization is taking place in the transition state. Polar solvents solvate these ions by an interaction of the solvent's dipole moment with the charge of the ion. Protic solvents such as alcohols and water are even more effective solvents because anions form hydrogen bonds with the halogen atom and cations complex with the non-bonding electrons of the oxygen atom. So for example, if this is the alkyl halide, so what happens is will ionize to form the carbocation, and of course we said it has to be stable, and the tertiary carbocation and secondary carbocations are the ones which can easily form, but primary and methyl hardly form. So this form, and also they form also the halide ion. So you have carbocation which is positively charged, you have the halide ions which are negatively charged. So if you have a solvent, for example, an alcohol solvent, protic solvent, it means they will stabilize this positive charge and also the negative charge. So which portion of the alcohol is going to stabilize the positive charge or the carbocation? Of course, the lone pair of electrons which are negatively charged, so they stabilize the positive charge. So this portion of the alcohol molecule will tend to donate electrons towards reducing the positive charge. Of course, reducing, and when it becomes completely stable is when this positive charge is reduced to zero. So even reducing it a bit is stabilizing. From a higher charge to a lower charge, it's stabilizing it. So they tend to surround to reduce that positive charge. So they'll be attracted to the negative side of the molecule, and the negative charge side of this alcohol molecule is at these two electrons. And these are positive charge, so negative charge. So they surround this carbocation and try to stabilize. And when it comes to the halide ion, which is negatively charged, it will be stabilized by the portion, the hydrogen part of the alcohol molecule, because the hydrogen part has partial positive charge because it's bonded to oxygen, which is more electronegative. So this hydrogen, this bond is polarized, and hydrogen has some partial positive charge, oxygen has some partial negative charge. So the partial negative charge will not attract, also will not be attracted to the halide which is negatively charged. It's the positive part of this alcohol molecule which will be attracted to the negative, the halide which is negatively charged. So because these hydrogens are partial positive, like you can see this is showing partial negative, positive, partial negative on the oxygen part. So this will be attracted without the halide will attract the hydrogen portion of the alcohol molecule. So they will be surrounded by the solvent molecules from the end, which is has got a partial positive charge. So and even this one here, this end has a partial negative charge, so it surrounds the carbocation. So that way they stabilize those charges. This portion stabilizes the positive charge, and the oxygen portion, which has got a partial positive charge, stabilizes the negative portion. So for SN1 reactions, which leads to ionization to form a carbocation and halide ions, usually protic solvents are the best solvents for these reactions because they stabilize the positive and the negative charges, which results from the ionization process. So protic solvents such as alcohols can solvate better than the ions formed during SN1 reactions. Unlike in the case for SN2 reactions, we saw protic solvents are not the most convenient because they drag they drag always the nucleophile, which is negatively charged, by forming hydrogen bonds with the nucleophile. But for this, when they form hydrogen bonds with the the leaving group, they always stabilize that leaving group, and which is positive. So the key word here is solvent, polar solvent, and protic solvents. Those are the most convenient solvents for SN1 reactions. What about leaving groups? The leaving group is breaking its bond to carbon in the rate determining or ionization step of the SN1 mechanism. A highly polarizable leaving group helps stabilize the rate determining transition step through a partial bonding as it leaves, that we've already discussed. The leaving group should be a weak base, very stable after it leaves with a pair of electrons that bonded it to carbon. Of course, when it comes to alkyl halides, halides are good leaving groups because they are weak bases. So this is what happens. So this is the alkyl halide. This is a tertiary alkyl halide. And this is the transition state. What happens? The transition state of the slowest step. So of course, what is happening at this step, the leaving group is trying to leave. But when you have a polarizable leaving group, it will still maintain overlap with this orbital, or the p orbital of the electrophilic carbon. So even when it's from still leaving, it still maintains, which is good for the transition state. It doesn't become so rapid, it's not reactive, because it's still, the positive charge is still being stabilized at a distance. So a good leaving group always is good for SN1 reaction, just like as for SN2 reactions. So finally, the leaving group leaves with the 2 electrons of this covalent bond to form a halide. And then also this carbon becomes sp2 hybridized. And of course, you have the hybrid orbitals, sp2 hybridized orbitals, which are on the same plane, and the empty p orbital. So in the transition state of SN1 ionization, the leaving group is taking on a negative charge. And it's because, of course, it's going to leave with 2 electrons of the covalent bond. So it takes on a negative charge. The carbon halogen bond is breaking, and a polarizable leaving group can still maintain substantial overlap. So next, we are going to discuss stereochemistry of SN1 reactions. Thank you.